Hi, so we're going to be talking about parallel lines and their properties. And so this is video number 1, and we're going to be talking about something I'm going to refer to as CAP, okay? And let's review what you learned yesterday. You should be able to identify 4 special pairs of angles that we've covered this far. So let's review of them. Angle 5 would be blank would have a same side interior angle of what? So hopefully you're saying that 5 on the same side of the transversal in this case is S. So angle 5 and angle 3 are same side interior angles. All right, what about alternate interior angles? Well, remember alternate interior on opposite sides of the transversal, and they're on the interior of the two lines, so between an M and L, so angle 4, its alternate interior angle would be angle 5. All right, what about corresponding angles with 7? Now remember, they correspond in the same location in relation to the lines and the transversal. So they're on the same side of the transversal in the relatively same location, which would be 7 and 6. Corresponding angles. What about angle 8? Again, it has to be on that side of the transversal, and the transversal again is S. So that would be 8 and 5. Angle 5, okay? Let's see what else we got. Angle 4 is blank alternate interior angle with what? So angle 4, we already did that one with angle 5. All right, so I'm going to ask you to answer those last 3 questions. 3 and 7 are what types of angles? 6 and 1 are what types of angles? And 7 and 1 are what types of angles? And we'll check that tomorrow. All right, so let's review what a postulate is. We've been working with the segment addition postulate and the angle addition postulate, which you have nailed. But remember, a postulate is something that we accept. It's a statement we accept without proof. We do not have to prove it, but it allows us to prove other things, okay? So today we're going to be talking about my favorite postulate that deals with parallel lines. I call it CAP, the corresponding angle postulate. The corresponding angle postulate. Well, since it's a postulate, you see this, I don't have to prove it. So cool. But what I'm going to tell you is that if 2 parallel lines are cut by a transversal, that means they are intersected by a transversal, cut by a transversal, then corresponding angles are congruent. So let me show you a picture, and we're going to draw this, okay? So here are 2 parallel lines. Well, I actually don't know they're parallel yet, but now I know they're parallel because I put that symbol on them. So I have 2 parallel lines, and I've got a transversal. So if I tell you that I give you 1 and 2, well, then angle 1 is congruent to angle 2 by the corresponding angle postulate. The corresponding angle postulate, which I refer to as CAP. That's right, like a baseball cap. All right, well, let's see this in action. The corresponding angle postulate in action with algebra. You have to look very, very carefully. I'm going to show you a couple things I love. The corresponding angles, if you notice, if I draw the transversal, they actually kind of form like an F. You see the F here? I'll draw the purple F. See that F? So one is on the top of the F and one's on the bottom of the F, because these can be very, very hard to see. So when I look at a picture, I also want to start with X. It's easier if you start in alphabetical order, so I'm going to start with X. And I realize that this X right here is corresponding to this angle right here. I even see the F. I'm going to take my highlighter. I'm actually going to make it a little bit thinner, maybe like right here. And I'm going to highlight. And I can see that the corresponding angles are on the inside of the F. So that tells me that this angle right here is X. Oops, is X. If this is X, this is X, because corresponding angles are congruent. Okay, if 2 parallel lines are cut by a transversal, corresponding angles are congruent. All right, so that tells me that 120 and X are a linear pair. So 120 plus X has to equal 180. So I subtract 120 and X has to be 60. Okay, now I'm going to move on to Y. Now it's a different transversal. Hopefully you're seeing that the parallel lines are these guys, and now this has become my transversal. Now X, which we said was 60, so I'm going to fill in the 60, is corresponding with 3y plus 6. So these are also congruent. So I can write an equation, 3y plus 6 equals 60. I can subtract 6 on both sides, so 3y equals 54. And then I divide by 3, and y equals, let's see, 18. All right, so that's an example of how to use the corresponding angle postulate. But what the big thing you have to remember is, if two parallel lines are cut by a transversal, corresponding angles are congruent, cap. All right, guys, move on to video 2.